Hello. We are looking at 5.4 multiple angle identities. And realistically, this section just gives us a bunch more identities. And so I'm going to show you some of the identities, point out a couple things, and then we'll do one example in this video. The first is our double angle identities. And I am going to mention, the first thing is U here is some angle measure. And so if I want to find, let's go with, and this is not a good example because it's not on the unit circle, but sine of 20 degrees, well, I could write that as sine of 2 times 10 degrees, right? Because 2 times 10 is 20, where 10 then is the u here. So that's what this is looking at. Of course, the whole point is to break down angles into something that is on the unit circle. So this example is kind of for naught because 10 degrees isn't on the unit circle, but that's okay. If you also notice, so we have sine of 2u is equal to 2 sine of u times cosine of u. We have tangent of 2u is equal to 2 tangent of u over 1 minus tangent squared u. But then cosine has 3 different options here. All 3 of these statements are congruent. Let me prove it to you. So let's look at cosine of 2u. 2u is the same as u plus u, right? And so we can use our sum and difference formulas from last time to break this into cosine of u times cosine of u minus sine of u times sine of u, which is really cosine squared u minus sine squared u. And look, we've got this first identity. But now, here's where we can keep going. Because of our Pythagorean identities, sine squared x plus cosine squared x is equal to 1, I could rearrange this for either sine or cosine to get these other two. Let's do one of them. Let's move sine to the other side. So cosine squared x is equal to 1 minus sine squared x, and now I am going to put this in here instead of cosine. So I have 1 minus sine squared u minus sine squared u. I can combine these sine squared u's into 1 minus 2 sine squared u. And now I have this second one, and I'm sure you can figure out we would do the same to get this third. So all 3 of these are viable options for cosine of 2u, and depending on the situation, one of them might be better than the others to use. And we'll see an example like that later. The second trio of identities in this section are known as the power reducing, which takes a function that is squared and reduces it to not being squared, lower the power. And actually, what you see here are rearrangements of the previous identities of our double angle. So sine of 2u, I can rearrange it to get cosine, oops, I said sine of 2u. Sine squared of u, we can rearrange it to be cosine of 2u over here, and same with all of the other identities with cosine and tangent. It's really just rearranging our previous identities. And as I mentioned the other day, none of these identities are necessary for you to memorize. Really, the only ones you need to know for sure are our Pythagorean identities, sine squared plus cosine squared equals 1, etc. These are ones that you will be always given and just expected to be able to use them. The last angle type is the half angle formulas. And in this case, they have plus or minus here, which means we need to decide which sign to use at the end. It's not saying I am getting both of these answers. It's saying the formula is basically not smart enough to determine which sign you would get. And of course, I will show you an example momentarily. If you want to pause this video to write these down for your notes, you can, but they are also on that 5.3 to 5.6 formula sheet, so you are welcome to just have that. Let's try an example together. Find the exact value of cosine of 105 degrees using half-angle formulas. So one thing that's kind of important here is that they specified in this problem that we want to use the half-angle formulas. Why is that important? Well, I could use angles on the unit circle and add them together or subtract them from one another to get 105 degrees, but that would be our sum and difference formulas. They don't want us to do that. They want half-angle formulas. Okay, so now what? We need to figure out what angle I would be so that I can, I'm at school and the bells are still ringing. Okay, where was I? We are looking at cosine of 105 degrees, and because they want us to use a half angle formula, we need to figure out which angle would I be that I divide by 2 to get to 105. So I set up some equation. 105 is equal to theta divided by 2, multiply both sides by 2, and I get 210, which is an angle on our unit circle. So now I am happy because I can write cosine of 105 degrees really as cosine of 210 divided by 2, and now I'm going to look at my formula. Cosine of u divided by 2 is equal to positive or negative square root of 1 plus cosine of u, right? In this case, u is 210, so cosine of 210 all over 2. Now I have an angle that is on our unit circle, and I can continue from here. Positive or negative square root of 1 plus, take a moment, look at your unit circle. What is cosine of 210 degrees? Hopefully you found that it's negative square root of 3 over 2, and that's correct, all over 2. Now I look at this and I think, ooh, that is not super beautiful, but it's okay. We're going to do some algebra to simplify it. And this is now really just practicing our algebra skills, so let's do it together. I don't like the fact that I have a fraction within a fraction. So I'm going to start with this numerator to make it one term. That means I need to get a common denominator. So I would have 2 over 2 minus the square root of 3 over 2, all still over 2. I can add those things together now. Oops, I was supposed to erase that. And so I would have still plus or minus, we'll deal with that at the end. 2 minus the square root of 3 all over 2, that's the numerator, still all over 2. And here's the important piece that seems to challenge people every single year. Now we have a fraction within a fraction, and what do we do when we're dividing fractions? Well, we multiply by the reciprocal. That means I take my numerator and I don't touch it. 2 minus the square root of 3 all over 2. And I multiply it by the reciprocal of the denominator. Now the denominator is the whole number 2. What's the reciprocal of 2? That would be 1/2. A lot of students get that wrong. Be very careful. You are smart. So now we can continue and simplify by multiplying these fractions. So we get positive or negative square root of 2 minus the square root of 3 all over 4. And there's kind of only one thing we can do here now. When we have the square root of a fraction, I can really write it as the square root of the numerator divided by the square root of our denominator, but the square root of 4 is just 2. And this is almost my answer. Even though I have a square root under a square root, that's okay. It is fine. I know it doesn't look that nice, but we're okay. Now we have to deal with this. Which sign are we looking at? Our original problem was cosine of 105 degrees. So let's consider, where is 105 degrees on our unit circle? It's bigger than 90, but not as big as 180. 105 degrees is probably somewhere around here. And let's think, if we go back to our all students take calculus, in the second quadrant, sign is positive. That means all other functions are negative there. So do I want to be the positive or the negative version? My final answer would be negative square root of 2 minus the square root of 3 all over 2. That is a final answer. Even though we have a radical under a radical, it is totally okay. We will look at the next two examples in class when? February 8th and 9th. I will show them to you. If you want to pause the video, write them down so you have them ready. Solve cosine of x plus cosine of 3x is equal to 0 on an interval from 0 to 2 pi. That'll be one we do together. And prove the identity. Cosine of 6x is equal to 2 cosine squared of 3x minus 1. Have a good rest of your day and weekend, and I will talk to you soon.